Hey everyone, let's look at number 4 in section 7.2. We're going to evaluate this integral, which is cosine of 5x plus 8 to the fourth power. Remember, when we see this again really means cosine of 5x plus 8. And then that output is then raised to the fourth power multiplied by itself 4 times. Okay. Um, the way there's a couple of ways we can proceed. I'm going to first just do a little substitution here. I'm going to let u be 5x plus 8. And then du is 5 dx, so I get 1/5 du is dx. And so the dx is 1/5 du, and this becomes cosine of u to the fourth power. So now how are we going to integrate this? Well, there's a couple of ways you can do this. One is by the reduction formula for powers of cosine. So if I ask you to use this, I would, of course, give this to you. This is on the short table of trig integrals that we have. You can find that in Brightspace. Um, so I'm going to use this, and of course, the value of n in my case is 4. Of course, my variable here is u instead of x, so I'm going to have u everywhere, if I remember. So don't forget we've got the 1/5 out here. And so now with n is 4, we get 1/4. Cosine 4 minus 1 is 3 to the third power. Sine of x plus what? 4 minus 1 is 3 over 4. And notice it's 4 minus 2, which is cosine squared. Now, there's two ways we can, so we still have to evaluate this integral, right? And there's two ways to do this. The way I want you to certainly be able to do it is with the following power reducing formula for, well, here's one for sine, but for cosine here. 1 plus cosine of 2x divided by 2, or 1/2 the quantity 1 plus cosine of 2x. So therefore, when I see cosine squared u, I can replace it with 1/2 1 plus the quantity cosine of 2u. Now I can integrate this, right? The 1/2 I'm going to pull out here, so I've got 3/20 times 1/2 is 3/40. The antiderivative 1, remember our variable's u, antiderivative 1 is u. And then the antiderivative cosine of 2u, just do a little substitution here, and we'll see that's going to be 1/2 sine of 2u, right? Because if I take the derivative of sine of 2u by the chain rule, I'll get cosine of 2u times 2 times the half will give me the coefficient of 1. So there's my antiderivative, and I just clean this up now. I'm going to go back to the original variable. Remember we said let u be 5x plus 8. So I'll have 1/20 cosine cubed of 5x plus 8 times sine of 5x plus 8. And then 3/40 times u would just be 3/40 times the quantity 5x plus 8. And then 3/40 times, make sure you distribute this through, times 1/2 is 3/80. Sine of 2u, well, 2 times u would be 2 times 5x plus 8, or 10x plus 16. Okay, so that's one possible answer. Some of you might have said, hey, when we got to evaluate cosine squared, could we have used the power reducing formula again with now n equal 2? And the answer is yes, you could. What would that look like? Well, I'm glad you asked. If I let n be 2, I can evaluate this. I'm going to go ahead and distribute the 1/5 through here. And I'll get 1/5 times 1/4, 1/20. Cosine cubed sine u. 1/5 times 3/4 is 3/20. And then what's cosine squared u? Well, plug in n equal 2. I get 1/2. Cosine of 2 minus 1 is cosine to the first power, just cosine u, sine u, plus n is 2, 1 minus, n minus 1 is 1 over 2. And then notice I get cosine to the what? N is 2. 2 minus 2, cosine to 0. What's cosine to the 0 power of x? Well, we consider that to be 1. So this is the integral of 1, which is just u. Remember, our variable is u. And so cleaning this up, going back to our variable, remember u again was 5x plus 8. I'll get this, which is really what we had the last time. Just pop that up there. Plus 3/20 times a half is 3/40. cosine of 5x plus 8, right? U is 5x plus 8 times sine of 5x plus 8. We'll talk about that because looking that we don't really see that up here yet, but we'll come back to that. And then here we got a 1/2. Don't forget I got to distribute this 3/20ths through. 3/20 times 1/20 is 3/40 u, which is 5x plus 8. And that's the same thing we have right here. So somehow, excuse me, somehow this right here must be equal to this. And it is, because if you remember the double angle formula for sine, sine of 2x is 2 sine of x cosine of x. All right. And so therefore, looking back at this expression, remember it was sine of 2u, sine of 2 times 5x plus 8. So sine of 2 times 5x plus 8 is 2 times the sine of 5x plus 8 cosine of 5x plus 8 by that double angle formula. And so because of that, this part right here is exactly equal to this part right here. You can see that's the case. When you plug out put the 2 there, the 3/80ths times 2 will give me the 3/40ths cosine of 5x plus 8 times sine of 5x plus 8. There's yet another way you could do this problem. I'm not going to work that out, but you could also have started with this power reducing formula for cosine here, and simplified it a couple of times and evaluate the integral that way. So there's more than one way to proceed, but this is using the power reducing integral formula here. Okay, hope this is helpful. And if you have questions, please let me know.